Okay, welcome everybody. Thank you for joining. I hope you're doing well. This is a sunny day here and I'm enjoying to tell you something about logging, actual plans, actual execution plans. I hope you will find it interesting. So, a little about me. SQL Server is my mother tongue, mother language. I have a small company, consultation, and this is my email. In June, I will have some free time for you. If you need help with SQL, you can hire me. Okay. Why actual execution plans are important? Well, everybody or most of you maybe were in a situation where in 3 a.m. something in production went wrong and they call you and or call DBAs and you later find out that it was some issue and you don't know what it was and you say, okay, if it repeats, if it explodes again, then I will maybe find out, maybe we'll be lucky to catch it and see when it happens what actually happened. And or you say, oh, okay, then run it again to explode again and we will then fix it to see what happened. No, that's not a good approach because you either have to be awake at 3 a.m. or you have to explode the problem again to make it happen again. And that's not a good approach. Good approach is to log. What I mean by log is that problem and everything relevant about that problem is already recorded in a file. And when you come to your work in the morning, rested and fine, refreshed with a coffee, you just connect, you see the mail, it was a problem, okay, you look at the logs and you see exactly what was the problem. Execution plan, all the required information are there and you can fix it. And even before boss comes to the job and you will say to your boss, I have solution for you, already is fixed. You don't have to repeat the problem, cause more trouble, etc. So it's very, really important to log. And how to log, you will see. I will tell something about lightweight profiling, which is a nice feature to record information about execution plans without taking much resources. Because traditionally, if you capture every execution plan, it was very expensive. It can bring down the server, basically. It's very expensive. Now it's not. So, and another great feature, live query statistics. And the demo about the problem that you may have run into. In fact, I had that problem in production and I will show it to you. Okay, we have do you see the screen? We have a small table, thank you. Okay, let's go to TestDB. We already created a small table. I will put some additional information here to make you richer, with your knowledge, not just about the topic, but a little broader, so you come out of this class richer with your knowledge about SQL. This small table has ID as primary key, int, and then it has a GUID, unique identifier. You know, people sometimes store these GUIDs, these huge 32-letter IDs, into varchar. And with the slashes, with these minuses, it can take even more than 32 characters. And some people put it in n varchar, so each character takes 2 bytes. So you have 72 or something like that bytes per value. But if you use unique identifier, you will take only 16 bytes. And I think there is a session right after mine, you can see that in details. Why we are saving bytes? Because less bytes means faster database. It is similar to racing cars, Formula 1. Why Formula 1 uses lightweight materials, carbon materials, instead of iron? for example, which is tougher, etc. Because of the weight. If you have an engine that is a force equals mass times acceleration. That means acceleration equals force divided by mass. You have a force of an engine divided by mass. Bigger mass, smaller acceleration. If you want to be faster, to have faster acceleration, you need to reduce the mass. That's why they are so eager to reduce the kilograms of Formula One. And the same is with SQL Server. We don't have kilograms, we have megabytes, we have gigabytes. You need to store the same amount of information in less gigabytes. Because CPU has certain limit around how many megabytes per second it can process, each CPU core. A disk also has a limit how many megabytes per second it can read or write. Network also has that limit. Everything has some limits in megabytes per second. If you reduce these megabytes for the same amount of information, you will get faster database. That's why we do it. This date, if you need date, you use date. Data type, not datetime. Datetime, no, datetime is not used, never. If you need date without time, you use date. If you need 100 of the second, you use datetime 2 in parentheses 2. That's 6 byte. If you need hours and minutes plus date, then you use small datetime. Datetime is used never. It takes 8 bytes and it's for nothing, basically for nothing. It's just a relic of the past, don't use it. Then text. Some people have characters which are Cyrillic, Arabic or non-US, non-ASCII, and they use an varchar to store that. But in 2019 we have Unicode. So we can use varchar and say UTF-8 collation, pardon, we did have Unicode before, but encoded as 2 bytes per character. Now we can encode it in UTF-8, which is 1 byte per character, and 1 byte per US character, SC character. All other characters can be more bytes. But if most of your text is American letters, then it really pays off because you will spend only 1 byte per ASCII letter. And you will save space and get a faster database. Okay, we already inserted some rows into that table and we will look how many? 6 rows, 8 kilobytes, 72 kilobytes reserved. So it's really small table. It cannot be smaller than that. Let's see the indexes. It has only one clustered index on ID, which is this one. ID, clustered index. Primary key, we didn't say clustered, but first unique index you create is clustered. Then let's see this value. Select star. I added 2 additional columns, which is data length. That gives you bytes. We are spending on that column. So you see these 6 rows, 6 GUIDs, date, something, blah, blah, text, ABCD in 2 different types, and how many bytes took normal and varchar. Normal and varchar took 8 bytes because it is 2 bytes per character. And UTF-8 took 4 bytes because these are ASCII letters, they fit into 1 byte. So 4 bytes for the same thing. And both can fit any other letters, Chinese, Cyrillic, Arabic, these weird Unicode characters, national characters, they both can fit. Okay, now let's see. Question for you. How long a delete of 1 row should take? This delete is with where ID equals 6. ID is a index column. It is cluster index. We have cluster index on ID. How long do you expect it to run? Question for you. Say something, anything. No ideas. Yes, that is a good estimation. That one would expect. Thank you very much for that. Be active. That is the one would expect normally. But let's see. Let me start execute. That already is too much because I have a fast computer with a lot of M2 SSDs and powerful processor. But it took almost 6 seconds. 6 seconds and something more. More than 6 seconds. What the heck? How is that possible? Table is 6 rows, few kilobytes. I mean, what is happening? What do you think? Why? Maybe it was the first time when things are loaded into memory. Let's try again. Let's try another one. Execute. Again, it's not microseconds. I mean, it's still executing more than several seconds. 5, almost 6 seconds. You see? Almost 6 seconds. Any ideas? What should I look? How should I troubleshoot this? Nobody has idea. Come on. Come on, something. Okay, somebody probably, yeah? Yes, exactly. What good thinking. Thank you. So let's look at this small table and see triggers. No triggers, sorry. Good idea, but no triggers. Only this index clustered on ID. This is real production situation. The names of the tables and maybe columns are maybe different, but that's it. That's what happens. So what would help? Exactly. Thank you very much. You're right. So let's look at execution plan. You are reading my mind. Control L, and now we will see the execution plan. I don't know, do you see it? Like this. So we have clustered index delete, looks good. On primary key, looks fine. But then nested loops with something, with what? What is this? Big child. What the heck? What is that? Why this plan is so complicated? It could be even more complicated, much more complicated. Single row delete can be a very complex operation if you have child table. Because when you delete parent row, only one row, if a big child table exists, SQL needs to ensure that this foreign key relationship is still valid. So it will need to check, are there any child rows referencing this parent? And it's a query. If you don't have index on that child table, it will scan that child table. And if the child table is big, let's say 10 terabytes, you will wait a few days. So deletion of one row can be very expensive. But let's see what's next. Let's see, you saw, if you press, for example, if you press Alt F1, Alt F1 will give you SP help on that what is selected. So you can see that table, columns, types, and indexes. You can see primary key is clustered unique on ID. But there is another procedure called SPXDetails, which gives you much more information. So let's execute that. And with that, you get similar to SP help, but much more information. So you see the columns. You see that it has index, pk small table, on ID, that it is clustered, has 4 rows because we deleted 2, 72 kilobytes, blah, blah. But you also see something more, included columns. You don't see that normally in SP help. And you see that it has child table, big child. And that child table has a foreign key, of course, to its parent. Does foreign key has index? No, 0. Foreign key doesn't have index. And then you know immediately you're in trouble. So you can go to this page and download it, I think, like this. blogxdetails.com, sqlxdetails.com, and then you go here, SPX details, you download it, install, and that's it. You have it. It's free. And you can even assign it to a key. You can assign it to a key, go to Tools Options, Keyboard Shortcuts, and you just use this SPX details in Ctrl F1 or some other key, and I press Ctrl F1 and I get the data. Even if you mark just a part, then it searches. It searches everything that has table inside. It does a lot of stuff, but I don't want to talk much about that, just a hint. So let's fix it. Let's fix it. Let's create index. We are creating an index on that child table to have an indexed foreign key column. And now we try to delete. What do you think? Will it be good now? Wow, elapsed 2 milliseconds. That's what we want to see. 5 milliseconds. That is, let's revert. And then let's see, do we have something? Yeah, we have some row. Let's try now without index again. It's again slow. So that index is really saving us. And what saved us was, what saved us? Execution plan. Execution plan saved us. So when you have execution plan, you can troubleshoot issues that are otherwise really hard to troubleshoot. And that's why we talk about execution plans. We have estimated execution plans in plan cache. So SQL has memory and a lot of caches, more than 80, 90, depends on version, a lot of caches in there, and one of the cache is plan cache, where all execution plans are held. And these execution plans are so-called estimated execution plans. They are created even before query is executed, before it starts to run. SQL needs to estimate how many rows each operator or table will give, and it estimates that without even reading the tables, like a crystal ball, and then figures out how to execute it, creates a plan may be good or bad, and puts it into cache. And that's estimated execution plan based on estimated number of rows. And yeah, please. Not necessarily. Query is just searching this child table on this column which is a foreign key column. So you only need index on that one column, which can be clustered, usually is non-clustered, and that entire table can be any type. It can be heap, it can be clustered table. It doesn't matter. As long as you have non-clustered index or any index of that foreign key column, it will be super fast. Yeah, no problem. So what details we have in estimated plan? We have plan itself. It's good enough variant, because if you have a very complex statement with a lot of tables and a lot of indexes, there are too many variations, permutations that SQL must try, and it cannot be done in real time. You would wait very long time for SQL to find the best plan. You maybe will wait hours. And therefore, SQL has compilation timeout. It gives optimizer only a small amount of time. You have this much time, and what you get by then, execute. So it is good enough variant of the plan he found so far. It may be not the best. Plan cost, we can help him to make the better plan, best plans, but okay, that's not the topic. Then you see plan cost. Plan cost is a number, some estimated cost. It's an estimated number of seconds for that to run, but on 25 years old PC. So if you have a cost of 5, that means this query is estimated to run 5 seconds on 25 years old PC. And of course, today computers and servers are much, much faster than 25 years ago. And cost of 5 means query that runs like this. So this is, if you have threshold for parallelism, for the queries you want to try to parallelize, if it is set to 5, cost threshold of parallelism, that means all super fast queries will be parallelized, which is ridiculous because you don't want to spend overhead of parallelization on very fast queries. You want parallelization only on slow, strong, or long-running queries. And this cost threshold of parallelism is too low. By default is 5. You need to set it. I usually set it to 100, 1000, something like that. Estimated number of rows you see for each operator. You see if the query had parameters, these variables or parameters, then parameters in fact, then values of these parameters are baked into plan, and you can see them. Values of this execution, first execution when plan was created, when first entered the cache, when last time entered the cache. So you can see these values and you can reproduce the same plan by using that same values. And you see missing index suggestions. You can open XML and see multiple index suggestions, but GUI shows you only first one. So it's sometimes useful to open XML. Actual execution plan, you get everything what you get with estimated, but plus runtime values. What happens is SQL estimates number of rows and then puts that plan into cache. And then execution occurs with a real number of rows, actual number of rows. And that actual number is different from estimated by a bit. It may be the same, but often it's not the same. And for next execution, it's even more different. It varies a lot. Actual number of rows can vary from execution to execution. Every single execution has own actual number of rows. And that can spread. That can be real like statistics, They can spread around the estimated value. Or that can be, if that estimated value was good, or it can really totally spread, not even around the estimated value, but the estimated value may be off the chart, totally wrong. So you see this in actual plan, you see actual number of rows, and if it is very, very different from estimated, you might have suboptimal plan, and that happens. Number of rows per operator is given, of course, and not just entire query, but per each operator. You also see weight statistics, how much query weighted for some resource, disk, memory grant, anything like that, lock, etc. So actual plan is better. Why it is better? We just told, but something else. Reality versus estimation, who is right? I mean, reality is always right. Estimation is just estimation. You can make very good estimations, but sometimes they are wrong. So sometimes they are very, very wrong, and then you have issues. Usually they are right. For majority of cases, it is super helpful. SQL does amazing job to produce a plan that really is great. But sometimes in tiny percentage of the queries, those queries get really bad plan. And then you need to help SQL to produce a better plan. So reality will help you with that. What happens is also that first execution gets some plan which is good for that execution, but next execution give you some other parameter values that are way off. They give you totally different number of rows, and for that increased number of rows, this plan is not good. You need to come up with some other plan. But SQL can hold for one query how many plans? how many plans are in cache for one query? Usually one. So you have only one query to cover all the cases, all the parameter values. If you search people by city, you have small cities and big cities. If you search for a big city that has a lot of people in your country, for example, majority of people, full scan is good. If you search for a small village, people in small village, it is better to use index. So, but you cannot have both plans in the cache. You can only have one. So you will always have this other value execute slow. And there is a way how to do it right every time, how to produce two plans, exactly what you want, but some other session. So actual rows processed, you see, and wait time per single execution. Each execution, how much time it waited. And we don't have this averaging out effect. You know what averaging out effect is? For example, you have a response from the disk, and it is all good, low, 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 and then spike. And that spike is more than, let's say, 30 seconds. It bothers customers. Customers complain they cannot do something. And then it goes down, and it's down again. And if you look at the average, you don't see the spike. Averaging out flattens out the curve. Averaging out flattens out these spikes, makes these spikes invisible. And if you are looking for averages, you will never see these short problems. If the problem was short, you will not see it. Customer calls you, say, I had a problem, I don't see it, because you're looking at averages. Then another great feature which is live query statistics. Live query statistics looks like the picture below. If you can see these lines moving, imagine that as rows or packets of data moving from the right to the left, from the rightmost operator to the left. And you see that for the query that is running just now, it didn't yet execute it. And that's why it is best for the queries that are long running, that are running right now, and or the queries that never finish. Maybe you are logging only queries that finished successfully, but this one never finishes and you will never see it. So this is super good for these super long queries that never finish. And you see number of seconds per operator, because maybe some operator finished and will stop counting seconds. Then you will see how much time was each operator active. You also see estimated number of rows at the bottom. So estimated number of rows is 176,000 here, but actual number of rows read so far is like this. And then a percentage of actual so far from estimated. And then, because actual can be way different than estimated, you can see that operator finished with 50%. It got to 50% of estimated and finished. That's normal. Or it can go twice as high as estimated number of rows. So you can see it 200% and then finished. So this percentage is not something you should be. I mean, that just shows you how off it is from estimated value. Very useful, very useful. You can see if operator is stuck, what finished, where it is running right now, which branch is now executing. So you know where to focus, where to concentrate. So you see actual duration. You can view that using this DMV, DMX query profiles, or activity monitor, which is not the best app. I believe they are, maybe SQL Sentry gives you that, I'm not sure, but you can see it in activity monitor, let's say. So we have live query statistics, and to use that for not just for your query, but the query in SQL Management Studio. You can use it for any query that runs on the server. any query that runs on the server from any user, you can view this live query statistics, this live plan as it executes. And how to do that? You need to enable trace flag 7412. And then you will be able to see this thing. It takes some resources. In fact, in SQL 2014 you can use it, but it takes a lot of resources, very intensive. So it's not recommended to do it on SQL 2014 because lightweight profiling version 1 is not that lightweight. Then in SQL 2016, if you have certain cumulative update installed, and 17, SQL 17, 2017, the lightweight profiling is version 2, it's better, it's more lightweight, and enabling this trace flag is not that bad. It's really super lightweight, you can use it without issues. Unless your CPU is constantly 99%, then don't. So you can use it on this version, 2016, 2017, and enjoy your live query statistics execution plans. In 2019, trace flag is even not needed. It is on by default, and you just have them right out of the box. And lightweight profiling is even better. And in 2019, you have 2 additional options: lightweight query profiling per database. So you can, inside your database, turn it on or off, not for entire server. You can, on database level, turn it on or off, and you can turn on or off last query plan statistics to see runtime statistics of last execution. Yeah, I'm listening. Yes, thanks for the question. It is, you can log actual plans and estimated plans. In fact, estimated plans are, if they are still in the cache, you can take them from the cache. There are DMVs where you can see the plans in the cache, and you just pick one that you are interested in, and then you can save it and then use it later for analysis. So you can save both estimated and actual plans, and you can even log them automatically. So, which I will show you. This whole session is about that. So I will show you right now with extended events and something even better than estimated, actual plans. So there are multiple methods to log them, and some of the methods are not good. Some of the methods are good. Let's see first method. You can use event query post execution show plan. Maybe you saw it in Uwe's session. That event exists on older versions and all versions basically. Even with SQL Profiler, there is equivalent event which you can catch and see actual execution plan. But it is very resource intensive. It is very resource intensive. You cannot, you cannot filter it, and it will take a lot of your CPU. It will basically, it can bring down the server. It's not recommended. And that's all you got in older versions. But from SQL 2016, there is a hope. There is something better. There is event query plan profile. It is lightweight. It doesn't take much resources. Super lightweight, in fact. And it will log you execution plan. But it has one drawback, big drawback. It logs nothing. Basically, it logs nothing unless you add a special hint. And that special hint is you add to the end of the query of the command option, use hint query plan profile. And only the queries that have that hint will be logged. It's good if you have crowded server and you don't want to log all of the, lot of stuff. You then can focus only on one query, but you need to modify it. You need to add this hint. So you need to be able to modify the code. That's good if it's a stored procedure, but if it's something else, then not that easy. But in 2017, we have a new event you can catch with extended events. Query, post, execution, plan, profile. It is also very, very lightweight, almost nothing. And you can filter it and doesn't need any hint. So it is perfect. It can log actual plans all the time, filtered by duration, for example. You say, I don't want to log all execution plans. It would be too much data. It would be too, I want to concentrate, I want to focus only on slow queries. And then you specify, I want to log only duration bigger than 10 seconds or 20 seconds. And then your log will not be big, and you will be able to focus only on slow queries. So if you have SQL 2017 and up, you should log this, your actual plans with this event. So let's see the demo. Okay, it's another. How to log actual plans. Let me go to the test.db. Let's make sure we have that index. Okay, index is created. Let's see how big child looks like. You see, this big child table has only primary key column 1 to 3, etc. Some bytes, it's text. And you have a parent ID, which is a foreign key column, and all the values are 1. So all the child rows refer to single parent, which is parent with ID 1. Let me show you with that grouping. So I'm grouping on parent ID. I have 500,000 rows, 500,000 rows with parent ID 1. And then I will do a query. This query looks just this part. Is from big child, where parent ID equals a variable. And that variable is equal to 100. Because all the rows have only parent ID equals 1, this will, first execution will be parent ID equals 200, and that will give 0 rows, no rows. Then it will decrease parent ID, and then again we'll try to count or sum data. It just takes data length of this. Okay, it will get data length on the next number, which is 199, and also there are no rows with such parent ID. That means it will also be empty, no rows, 0 rows. And then that will cycle, less, until 1. When parent ID becomes 1, it will go here where parent ID equals 1 and will return us how many rows? Let's see, Control F1. Primary key, 500,000 rows, 4 gigabytes. Non-clustered index on parent ID, also 500,000 rows, but less bytes, because clustered index is always bigger. It has all the columns. This one has only sub-selection of columns. Okay, so we have multiple executions, out of which the last one is the biggest, because it gives all the rows. Let's run that with the query profiler. So I will turn on the profiler. And I will choose event to catch actual plans. I already have prepared template with that event selected. And that event show plan XML statistics profile. And statement, which statement completed to see. And let's run it. Let's run it. Execute. So while it is executing, we should see that you see the event name, which was captured, text, and then we see row counts here. So the last execution if we reach it. Still we are not on the last execution. But let's see this execution. We have this plan, show plan event, and we know that from this index seek on the parent ID column, index on parent ID column, we actually got 0 rows. Estimation was 1 row, but we got no rows, because that condition gave us no rows. So no key lookup didn't happen. Number of executions is 0. It didn't execute because this returned nothing and nested loop didn't go that way. But the last execution, you see it returned 500,000 rows, this last execution. And what was the plan? Actual plan was this. Same plan, same shape of the plan, but number of rows is very, very different. And you can see that here is 500,000 rows actually, while estimation was 1. So this plan is probably not good for this last execution, because estimates and actual are way different. And you also see how many seconds, how long this operator executed. Per each operator, how long it executed. So this one finished fast, but this key lookup was terrible. It was running almost 33 seconds. So if we could get rid of this, that would be really good. Okay, now you see how useful this is, but if you do this on the production server with this event, production server will probably stop, because it's so intensive. If you have thousands of executions per second, unviable, unusable. This is just for like demos. And that's all you have before 2014 and down. And you can save this, somebody asked, you can save this if you go to edit, somewhere, like this, right click, extract event data. So you need to right click here, extract event data, and then you save XML plan to the file. Bad plan. Okay? You can save that like this, extract event data. Let's see, can we filter that out? Let's filter that out. If we can go to the filters and use duration is greater than 1000 milliseconds. That is 1000 milliseconds, it is 1 second. Will that, or reads, but let's say duration, okay. Will that make less plans captured? Let's see. Wow, no. It just eliminated this second event when the query was finished, but we still have 200 plans, we don't want that. Why didn't capture this? Because you see duration is empty, null. That means filter doesn't work. If you go here to filters, duration greater than 1000, but this is cleared. Exclude rows that do not contain values. Exclude nulls. So it will include nulls, that means you will see it. If I click here, then you won't see anything basically. And it will still be performance intensive, it's not good. Don't use this, that's the point. Okay, let's then let's use something else. Let's use a query store. So we go to the database, right click, properties, then we go to query store, and it is already enabled. It's already enabled. And that means we can see the results. What queries could store got us? So I think we have that here. Overall resource consumption, And then you need to select the time. You click to configure to see just the recent time, not last month, but last hour, for example. Okay. And from the last hour, this is axis is the time. So the recent events are to the right. So let's see, execution count is 200. You see 200 execution count. Duration, this was big duration, but it's all the same time. Okay, last execution. I click here, then that selected the time range, the time slot. On this time slot, we are viewing top queries, top resource consumption queries. And the top one is this one, the only one. But what do you see? You see estimated number of rows is 1. Oh, not very good. I want to see this execution that was slow, the last execution. And I cannot see that here, but maybe, just maybe, I can go to grid format. And in the grid format, or even with additional details, I get much more information. So I have execution count 200 for that plan, and I have total row count, total logical reads. But it is total, a sum. If you want to see per execution, you need to divide that number with 200, with execution count. So we can export this row into Excel, for example, and then add additional columns to see averages, average duration, average logical reads, average CPU. But that is averaging out. We would average out this value, we would divide by 200, and we would flatten our peak. We have only one peak that would now be flattened. So it is very helpful, it is very good, I recommend you to use it, it's a really nice feature. Sometimes can solve you a lot of effort. And but it averages out things and cannot be used for these spikes. It doesn't capture single event. It averages out in the time frame. Then, next thing I can show you is extended events, how we will capture it with the real stuff, extended events. So let's use the script for 2017. You remember, we can use it on 2016 without any overhead, but it is only limited to one query, to the one you added the hint, and on 2017 it's perfect. You don't need a hint. So if we create it with a script, you can create, I need to go to SQL CMD mode, and then you specify where you want these log files to be placed, in which folder, how it is named, how many microseconds. These are not milli, these are micro. That means 1 millionth part of the second. 1 million equals 1 second. So this is 1 second. Everything above 1 second will be recorded. You can place here 10 seconds. So everything above 10 seconds will be recorded. And this is the event to use. So this event exists from 2017 on. You cannot use it in 2016. In 2016, you can comment out and use this event, which captures only the executions with the hint, which have this hint added. So, but I already ran that, and if you see on the management and extended events sessions, you see that this session, actual execution plans, is running, and we can view the log by double-clicking here. And it opens, and we can order by the latest one. And you see time duration in microseconds. So this is 34 seconds. This one is interesting. And you can see a bunch of columns there. You can right-click and show them in the table here, or hide them from table if they are already present. But this column is interesting to us. This show plan XML. So to display that, we will copy the cell and we will paste it here in SQL Sentry 1 Plan Explorer. I'm just pressing paste or Ctrl V. And it will give me a plan diagram. I can even make it, I want to make it float. I want to make it float, maximize. And you can see really big plan of actual execution from that file. I was reading the file. That file is really on the disk. You can take it in the disk, from the disk, zip it, send it to some consultant to look at it, to recommend you how to fix it, and that's it. So you don't have to save each plan. You can even use this technique on any plan you execute. For example, if I execute select star from sys databases, and I will use actual execution plan, and this is the plan, I can right click and, for example, you're on production server. You're not allowed to install SQL Sentry there. But you can say show execution plan XML, and you say select all, right click copy or Ctrl C, and then you go to your machine with SQL Sentry, you say new plan, and paste. And I just pasted it. So I should see, voila. You can see the actual execution plan from production without installing any software. You only need SQL Management Studio. And on your machine, you need SQL Sentry Plan Explorer. So let's see example on 2016. On 2016, how it looks. It looks basically the same. The only difference is this line. You cannot use this nice event, which logs your actual plan without any additional stuff. You must use, unfortunately, this one. It is lightweight, but you need that hint. So you need to add a hint. And it will work just normally, but just as this one, but it will capture nothing unless it has this hint added. So let me go back. So if you want to these scripts, and you don't have to write it for yourself. They are already written for you. You can go to this page, download them, install on your server. They will log not just actual plans, they will log slow queries, stuff like that. And you will have in the log files, you will have all the required info for performance troubleshooting, for a consultant to take a look what happened and immediately gives you recommendations. So it's really good. Overhead is nothing, really nothing. It's lightweight, super lightweight. You won't notice any difference with it or without that. It's not any new tool. It's extended events already included in SQL. So really, really nice. It also logs performance monitor counters. It is not any new tool. It is existing inside of Windows, this perfmon. It can log certain counters. This just configures which counters to log CPU, to log disk response time, and similar stuff, and some SQL counters, memory of SQL. And you have these binary log files, and you just zip them, send them, and everything is visible graphically, what happened on the server, without any new tools, without anything additional. So it just uses what you already have on the server. Just configures that instead of you. So you can see slow queries, errors, and timeouts. That means aborted queries, to concentrate on them, blockage, deadlocks, actual plans, everything. So you can from the June, you can hire me for this. So why actual plans are important? Because we don't want to repeat problem situation. We don't want to explode again. We want to have it logged, and when we get to the job and we have time to analyze them, or you send them to somebody else with a lot of experience who will tell you what was the problem from that. So we want to log actual plans, not estimated, because estimated plans are only estimation, that they are not the real thing. So how to capture, we saw that. We saw the feature of lightweight profiling available from 2016 and on. I mean, it is on 2014, but don't use it. It's not lightweight. So from 2016 and on, we have lightweight profiling, and it is really low on resources. You won't feel it much, almost nothing. And on 2019, it is on by default. This some features of it. Like query statistics, you can see for all the queries that I didn't show you. Here, if you go to if you right click the instance and then go to activity monitor, there you can see active expensive queries. Under active expensive queries, none are running right now, but you would right click and show live execution plan. And that would show you this moving execution plan. And but you need to enable it with trace flag 7412 on 2016 and 17. On 2019, you don't need the trace flag. You just go there and view your slow query. So that's it. Thank you very much. You just need to remember this email, ask anything, and thank you very much for participating. I'm very happy that you're here, and if you have any questions, please. Thanks. Sure. Copy, go to chat. I don't know how to view the chat. I will have to stop presenting for that. And then chat. Yeah, I see it. Paste. Here it goes. Paste it. I thought maybe it's better to do natural, to see my mess, to see how it really is. Not fancy at all. So just a small room. I'm a modest. Yeah. This one is still running, and no operator finished yet. If operator would finish, you would see full line. You wouldn't see that dashes, but you would see a full line. That means operator finished, and that is how you know this one finished. And the one that is stuck, let's say stuck, these which are moving means they are still executing. Let's say they are stuck, they are still executing. The one that finished, the one that has a full line here, this one is good, that one finished, that one is okay. But the ones that have these lines, that one is stuck, especially if it is, go to the first one you see to the right, that is moving some rows. It has these dashes, and you see number of rows increases. That one is still active, it is running. Maybe the later ones are just waiting for the right one operator to provide the rows. So that's how you see. That's how you see by this line. Sorry, I don't have it here. This is just a GIF animation. So when it finishes, line is full, and you will see part of operators have full line and part of operators have only dashed line. They are still running. Okay, no problem. Hi. Trace flag is 7412. Let me go to that. I think, yeah. Oh, I skipped it. 7412. That is the trace flag. You can use it on SQL 2017. It is great. Even on SQL 2016. But you need to add this hint. You need to add a hint to be able to use it. No, sorry. Oh, sorry, I mixed up. This is for live query statistics. No hints, no hints. So this is for live query statistics. You just need that hint and you will see this live query plan with moving rows from the operators. Sorry. Okay, thanks. Thanks, Uwe, who is a great guy. I like him. Okay. Okay, if no other questions. Okay, thank you very much. I was enjoying this and I hope you enjoyed it too as much as me. I will edit, I was recording this and I will edit the video. It will take me a few days. But I will post a link to the video and all the materials, that means presentation and scripts, demo scripts. You will have everything available and you can use it. You're free to use it. Thank you very much. Thank you too. And I'm stopping